Welcome everyone. በዚህ ፕሮግራም ላይ የምናየው ኤሌክትሮስታቲክስ ቤዝድ ወይም ነክ የሆነ ጥያቄ ነው የምንሰራው። ኤሌክትሪክ ፊልድ እና ኤሌክትሪክ ፖቴንሻል ላይ ያልሰራናቸው ፕሮግራሞች ስለነበሩ በዚህ ቪዲዮ የምንሰራው ምን ይሆናል? የምናየው ፕሮብለም ምን ይሆናል? ኤሌክትሮስታቲክስ ፓርት ይሆናል ማለት ነው። ኤሌክትሮስታቲክስ ላይ we know that simply electric field and electric potential of a point charge at a given distance or at any given radius r from the center. So ያንን ቤዝ አድርገን for multiple charge system electric field እንሰራለን ማለት ነው። So here we have given a question, and the question says find the electric potential and electric field at point P ነው የሚለው። So a rectangular shaped የሆነ ሲስተም አለን እዚህ ጋር እንደምትመለከቱት። now ጥያቄ የሚጠይቀን at point P ላይ due to these three charges Q1, Q2 እና Q3 we need to find the electric field due to these three charges at point P here. So ምንድነው የምናደርገው? From our given from the given information here, as you see, we need to specify a distance between the point and the charge, individual charge. So as you see here, between charge 1 and the point P is you found a distance of what? Let's say y equals 3 centimeter. And of course ሌላ ምን እናያለን? You'll see that the point between Q3 and point P is, let's say, x equals 1 centimeter. And of course between the charge Q2 and the point P is, you would found distance which is, let's say, a separation distance of r. The separation distance r is simply found using Pythagoras theorem. So you will find that r equals square root of x squared plus y squared. So with little substitution, and you will find that r is approximately square root of 10, or simply without any calculation, square root of 10 times or centimeter ማለት እንችላለን። So root 10 centimeter አለ። Finally we will solve out the r value like electric field እና electric potential ስንሰራ ማለት ነው። So አሁን ዌስት ሳናደርግ ጊዜ ወደ ፕሮግራማችን ስንገባ አሁን Q1 it will have a point at point P electric field pointing in what direction? In the down direction. Since the positive charge has a point, the direction of for electric field for positive charge as always is away from the charge. So we place here the charge away, since our test charge is what? The positively charged. So, and also this is, let's say, E1. So we need to finally find the direction, and ምንድነው የምናደርገው? የፖይንት ላይ የሶስቱንም ቻርጆች ኮንትሪቢዩሽን ሳማፕ አድርገን ነው ፋይናል ኤሌክትሪክ ፊልድ የምናስቀምጠው። and finally we have E3. So E3 is just the electric field due to charge 3. As you see, it's in the negative x direction. And of course finally you have a negative charge Q2. So yeah, Q2 negative charge ስለሆነ it should point toward itself, the charge. So this is the electric field E2. So ምንድነው የሚሆነው? The resultant at point B, the resultant of the electric field EP is the sum of all three electric fields, E1 plus E2 plus E3 ነው የሚሆነው ማለት ነው። መልካም። ሶ ምንድነው የሚጠበቅብን አሁን? ኢንዲቪጁዋሉ እያንዳንዱን ኤሌክትሪክ ፊልዶችን ኮምፖነንት ዋይዝ ኤክስፕረስ ማድረግ ነው የሚጠበቅብን። ሶ እንደ ነው ኮምፖነንት ዋይዝ የምንጠቀመው ጀስት ካርቲዣን ኮኦርዲኔት ተጠቅመን ሁሎችንም ኢን ተርምስ ኦፍ አይ ኤንድ ጄ ኤክስፕረስ እናደርጋቸዋለን ማለት ነው። በዩኒት ቬክተር ፎርም እንጽፈዋለን ማለት ነው። ሶ ከምንነሳለው ሌትስ ቢጊን ፍሮም ኢዋን። ሶ ከኢዋን ስንነሳ here E1, as you see, first we need to find the magnitude of E1. So the magnitude of the electric field is simply the electric field constant, simply the electric constant Ke of the column constant times Q1 divided by the charge, the distance between the point and the charge, the Y. So in fact, Ke is an electric constant. It is about Ke, you'd get 9 times approximate value in most of the it's the power of 9. It is Newton meter squared per coulomb squared now, so we don't need the unit here. Was the proper unit እናስቀምጣለን ማለት ነው። So here the Newton, let me put for the sake of ለማሳየት ያህል Newton meter squared per coulomb squared. Of course Q1 is simply the charge 1, that is 2. Here 3 micro coulomb ተሰጥቶናል ማለት ነው። ከላይ እንደምትመለከቱት እዚህ ጋር Q1 is 3 micro coulomb, simply 3 times 10 the power of minus 6 coulomb ማለት ነው። So the proper unit መቀየር አለብን። Then divided by the distance, separation distance, y is what 3 centimeter. So that would be with simplification get minus, sorry, here 3 times 10 the power of 2, 10 the power of minus 2 meter ማለት ነው። So proper unit ገልጻለን። So finally it will be easy to find E1, the magnitude. And of course here we will square this thing, and of course with simple simplification we'll get 3 times 10 to the power of minus 7 Newton per coulomb magnitude እናገኛለን ማለት ነው። So this is E1, the magnitude of E1. So in vector form E1 is given by what? So as you see here, the direction is in the negative direction. It's just away field. ስለሆነ minus 3 times 10 the power of minus, sorry, here is no minus, it's actually plus Newton per coulomb. It's in the J direction, unit vector of J. So now ጥሩ አንድ ነገር ቀለናል። ፋይናሊ ምንድነው ሶልቭ የምናደርገው E2 ነው። So first let's find the magnitude of E2. So E2 is simply Ke and the distance between E2 here and the point P is square root of 10 divided by 10 centimeter. So this is x squared plus y squared. So after with the simple substitution, you will find a magnitude of E2 approximately 1 point. Let's substitute first. That's just 9 times 10 to the power of 9 times 2 microcoulomb የተሰጠን እዚህ ጋር ማይነስ 2 microcoulomb ማግኒቲዩዱን ስለምንፈልግ ደኑድ ሂር አያስፈልገንም። so 2 times 10 the power of minus 6 coulomb divided by here the x is 1 centimeter, y is 3 centimeter, and of course by squaring that you would get square root of 10 squared, or simply 1 times 10 the power of minus 3 እናገኛለን ማለት ነው። so meter, and of course here we have a unit of Newton meter squared per coulomb squared ማለት ነው። fact after with simplification you would get approximately just 1.8 times 10 the power of 7 Newton per coulomb. This is the magnitude of E2. so direction wise እንዴት ነው ኤክስፕረስ የምናደርገው? አሁን እዚህ ጋር ከደረስን ዋናው so this angle theta should be found first. so let me write here the above diagram. so here we have a charge q2. now we want to find here is the direction of E2. now after finding this angle theta one can find simply the x component and the y component. so what we are going to do is find the angle theta here. Here the angle theta can be found just simple the trig relation. angle theta is tan inverse of what's y over x ማለት ነው because there's a rectangular arrangement ስለሆነ ቀላል ነው እዚህ ጋር ማግኘት theta. so this plus theta equals tan inverse of 3 centimeter divided by 1 centimeter. You would get approximately a value of 71.6 of degree. now theta ካገኘን it's easy to express the y component, that's the ey, and the x component of the electric field. so the next thing that we are going to do is find the electric field along the y direction. so the electric field along the y direction is simply ey, or electric field E2, here E2 sine of theta, and of course with direct substitution or simply የመጀመሪያ ያገኘነውን E2 እዚህ ጋር እንዲሁም አንግል ቴታን ኮንሲደር በማድረግ finally if you plug the numbers and you would find that approximately just use your scientific calculator and you would found that 1.7 times 10 the power of 7 Newton per coulomb. so this is the y component of the electric field, then the x component of the electric field is simply E2 cosine of theta. so I found E2, we know that theta after this simple substitution you would find that this is 0.6 times 10 the power of 7 Newton per coulomb. of course so the componenቶችን ካወቅን ቱን በቬክተር ፎርም ስንጽፈው ምን ብለን ጽፈዋለን? so ex in the I direction plus ey in the j direction, or simply with a unit vector of j. so you would found that this is 0.6 times 10 the power of 7. in fact let me in the I plus 1.7 times 10 to the power of 7 in the J direction. Let's put it, this is Newton per coulomb. So this is E2. Now E2 አግኝተናል። finally that's የሚቀረን that we are going to find is E3 ወደ ፕሮብለም ስመጣ as you see here charge 3 or 5 microcoulomb, it will have an influence at point B electric field. So due to that we need to find the E3. So the magnitude of E3 is simply the charge, the electric constant times the charge 3 divided by the separation distance squared, that is x squared. So this is 9 times 10 to the power of 9 Newton coulomb Newton meter squared per coulomb squared times 5 times 10 to the power of minus 6 coulomb divided by the separation distance is 1 centimeter. Squaring that, you would get 1 times 10 to the power of minus 4 meter squared. And in fact, with simple substitution and simplification, you would get approximately, here I have got 45 times 10 to the power of 7 Newton per coulomb. So በቬክተር ፎርም ስንጽፈው E3 ብለን እንጽፋለን። E3 is, as always, it's pointing in the negative x direction. As you see here, it's pointing in the negative x direction. So ታች ስናስቀምጥ it should be in the negative x direction, minus 45 times እዚህ ጋር ያው በሳይንቲፊክ ኖቴሽን ማስቀመጥ ይቻላል፣ ግን ለሰማፕ ለማድረግ እንዲመቸኝ ነው በዚህ ተውኩትኝ። ኒውተን ፐር ኮለምብ እንደ ኔጌቲቭ ኤክስ ዳይሬክሽን ማለት ነው። ሶ ምንድነው አሁን ያገኘናቸው አራቱንም ኤሌክትሪክ ፊልዶች ሶስቱንም ኤሌክትሪክ ፊልዶች አግኝተናል። ሶ ኢዋንን አግኝተናል፣ በቬክተር ፎርም ኤክስፕረስ አድርገናል as you see here. So let me ለየት ባለ ፔን እዚህ ጋር እንትን ልበለው። ይህንን ፊልድ ኮንሲደር እናደርጋለን። this is E1 and E2 በቬክተር ፎርም ኤክስፕረስ አድርገናል። So we know just how to add vectors component wisely. So it would be easy then to find የመጀመሪያው ስንነሳ ያነሳነውን ፕሮብለም ማለት ነው። እዚህ ጋር ያነሳነው እዚህ ጋር ነው ኤሌክትሪክ ፊልድ at point P simply the sum of all electric field, and finally here it would be simple arithmetic የሚሆነው ማለት ነው። So E at point P is simply add them with component wise አድርጋችሁ አድርጉት። Here and I will put the whole result. So it's simply E1 plus E2 plus E3. Of course you would get a result of 40 minus 44.4 times 10 to the power of 7 Newton per coulomb. That's in the I direction, minus 1.3 times 10 to the power of 7 Newton per coulomb in the J. So you will find the electric field of this magnitude ማለት ነው and direction. So ጥያቄው ምናልባት ዳይሬክሽን ብትጠየቁ it would be then simple to find ዳይሬክሽኑን ኤክስፕረስ ማድረግ ከፈለግን so an angle theta of this direction is say theta prime ልበለው, it would be tan inverse of E electric field along the y divided by electric field along the x, and you should express finally also the direction. I leave it this for you እንድጨርሱት ለራሳችሁ ዳይሬክሽኑን ስፔሲፋይ ማድረግ since we have seen on vector part how to find the direction of a vector using a tan inverse function ማለት ነው። so that will be nice now ሌላ ኮንሲደር ማድረግ ያለብን ምንድነው at point b ጥያቄውን ዲማንድ ከሚያደርገው ኤሌክትሪክ ፖቴንሻል ነው። so here as you ጥያቄው እንደሚጠይቀን ኤሌክትሪክ ፖቴንሻል እንድንፈልግ ይጠይቀናል። so at point b ላይ ያለው electric potential would be the superposition of electric potential due to all individual charges. So electric potential V at point B is the sum of simply all electric potentials like V due to charge 1 plus due to charge 2 plus due to charge 3 potential due to charge 3. So now with a simple let me just calculate individually or simply express the expression the potential of any point charge at a given distance is given by what the electric constant Ke times the charge divided by the separation distance. We know this thing. So the ሶስቱም charge individually ትሪት እናደርጋለን ማለት ነው then አድ እናደርጋለን ማለት ነው። so generally እንደዚህ አድርጌ መጻፍ እችላለሁ። so the electric potential due to charge 1 at point p ላይ እዚህ ጋር ድሮው ለማድረግ ያህል ከላይ ያየነው ሶስቱም ቻርጆች እዚህ ጋር የሚኖራቸው ጊዜ they have a distance separation distance that's y of course this is charge 3 have a distance x or of course charge 2 has a distance of square root of x squared plus y squared and then simply this is a potential v1 ታገኛላችሁ እዚህ ጋር v2 ካገኛችሁ በኋላ v3 ታገኛላችሁ then add them superposition ነው የሚሆነው direct since scalar quantity ስለሆነ ማለት ነው and of course this is ke q1 divided by the separation between q1 and point b is what we have saying that's y plus the separation between charge 2 and p is x so that's q1 divided by x no actually it's square root of x squared plus y squared plus finally ke q3 charge 3 and point b has a separation distance of x. And of course let me just bring some common variables here ke and here commons are q1 divided by y plus q2 divided by square root of x squared plus y squared plus q3 divided by x. Now what we will find here is what 9 times 10 to the power of 9 times square root I mean in the bracket here we'll put the charge the charge is to 3 micro coulomb that's 3 times 10 to the power of minus 6 divided by the separation distance is 3 centimeter that's 3 10 to the power of minus 2 meter plus q2 has a unit of I mean a magnitude of negative charge ስለሆነ we should express the charge here minus 2 times 10 to the power of minus 6 coulomb ነው just for the sake of simplicity unit እንትጫዋለሁ just finally then the distance is simply a square root of 10 times 10 to the power of minus 2 meter finally plus 5 coulomb charge አለን 5 times 10 to the power of okay እዚህ ጋር ቦታ ይበቃኝ አይደለም let me go once again here of course this just 5 times 10 to the power of minus 6 oh okay minus 6 divided by the separation distance which is 1 centimeter which is 1 times 10 to the power of minus 2 then እነዚህ ነገሮች ሳም ብታደርጉ you will get a potential of እዚህ ጋር ነው ካልኩሌት አድርጌ ሪዛልቱን አስቀምጣለሁ that would be 5.46 ታይምስ 10 ዘ ፓወር ኦፍ 6 ኦፍ ቮልት ነው የምታገኙት። ሶ the unit of potential source potential is volt, so this is the potential at point p ማለት ነው። ሶ ኢን ፋክት ከዚህ ፕሮብለም ተወሰነ ኪ የሆነ ነገር አግኝታችኋል ብዬ አስባለሁ። ሶ ሌላ ኮንሰፕት ተጨምሬ ደግሞ ኔክስት ላይ ደግሞ የምናየው ነገር ይኖራል። ሶ ሲ ኦን ኔክስት ታይም። ባይ ባይ።